Hello everyone, this is the London Information Retrieval Meetup, and this is a recording for the talk How ChatGPT Works in Information Retrieval Perspective from the meetup of the 21st of February 2023. As usual, let's start from the introductions. My name is Alessandro Benedetti. I was born in Tarquinia, an ancient Etruscan city in Italy, and then moved to the United Kingdom 10 years ago. And I'm a research and development software engineer. I'm the director of Sease, my company, and I will briefly talk about it in the next slide. And I have a master's degree in computer science. I am the program committee member of various international conferences in information retrieval, specifically the European Conference in Information Retrieval, the Special Interest Group in Information Retrieval, and the Sease. I'm an Apache Lucene and Solar committer and PMC member, Elasticsearch expert, and in general, I'm really passionate about integrating machine learning and natural language processing techniques with search and information retrieval in general. In my spare time, I love playing beach volleyball and snowboarding when I go back to Italy for holidays. So let's talk a little bit about my company, Sease. It's been founded in 2016. We are headquartered in London, but we are distributed as a company. We have people all around Europe and in the Middle East. We are open source enthusiasts. We work with Apache Lucene, Solar, Elasticsearch, OpenSearch, and we are active community contributors. So we are not just using open source software, but we are also contributing back to it in form of support, mailing lists, code, evangelization at conferences, and we are the host of the London Information Retrieval Meetup as well. And we are active researchers, so we are working actively in the domain of neural search. We are the author of the contribution in Solar 9. Learning to rank, we are maintaining the feature in Solar and extending it, and in general working and researching in this area. Document similarity, which is the more like this functionality, where you take an input a document and you want to find similar documents. We've been extensively working on it and contributing back to Lucene. Search quality evaluation, which means the ability of measuring the quality of your search. We contributed an entire open source library for that, Rated Ranking Evaluator, and we are actively working in this direction with our clients. Finally, relevance tuning, which to a certain extent groups all these activities. I leave here some references of our website and blog. We try to blog as much as possible, and also our repositories and Twitter handle. Today, we're going to talk about ChatGPT. There's a lot of hype around this technology, and I wanted to give you an idea of how it works internally, especially the target of this talk are information retrieval practitioners and anyone interested about the engineering side of this interesting product. We are going to start from the artificial intelligence techniques that powers ChatGPT, and then talk about the internals and the steps necessary to obtain such an interesting product. And these steps are the supervised fine-tuning model, so obtain the SFT model, train and fine-tune a reward model, and finally, the proximal policy optimization. Finally, we're going to wrap it up with the possible impacts on the information retrieval world. Without further ado, let's start from the basis. So what is it? ChatGPT, it's a product capable of generating text in response to a prompt. A prompt is just text, like a sort of query. And GPT stands for Generative Pre-training Transformer, and it is based on generative artificial intelligence-based large language models. It has a sibling model, InstructGPT, and most of the explanations you will find in this talk come from the paper about InstructGPT and various blogs that summarize that paper. So let's start from a blog post from OpenAI, the authors of ChatGPT. We train this model using reinforcement learning from human feedback, using the same methods as InstructGPT, but with slight differences in the data collection setup. This means that the main ideas and tech behind ChatGPT are supervised learning, deep learning, pre-trained large language models, and finally, reinforcement learning from human feedback. So let's explore each of them to have an understanding of these techniques. Let's start from artificial intelligence, which is a branch of information technology that study techniques to simulate some sort of human intelligence, human behavior, and is a huge area of study and contains various subsets of techniques. Among them, machine learning studies how you can learn from experience in a machine way. So effectively, it studies algorithms that are able to learn function from existing training datasets. Finally, deep learning is a subset of machine learning and studies how to solve machine learning-related problems using an implementation based on deep neural network. Deep means like multi-layered neural networks. A pre-trained large language model is currently, it's one of the buzzwords around, right? Large language models, they are everywhere. And first of all, they are mostly based on transformer architectures, following up like the BERT family, for example, of large language models. And nowadays, if you take a look to the leaderboards, you can find a lot of different variations of such models. Basically, these models are trained to satisfy two possible tasks: next token prediction and masked language modeling. The next token prediction task takes in input a sequence of words and target to predict the following word, the next word. An example is Anna is a potential autocompletion could be sister, friend, marketer, comedian. A masked language modeling, on the other hand, takes in input the same sequence of words, but with one word masked hidden, and it needs to predict that word. An example could be Jacob masked reading, and fears, loves, enjoys, hates could be possible token to replace the mask. Effectively, a large language model estimates the probability of a word to fill the gap. This can be like the next token gap or potentially the masked token gap. And when you train a model to satisfy these sort of tasks, you get it to learn the statistical structure of the language. And these models are pre-trained on huge quantities of text. So it's very expensive to train such models. You require 1 trillion of documents and a long amount of time. Reinforcement learning is a technique in artificial intelligence to learn by executing actions on a system. So you start from the input status of your system encoded as a vector. A policy network takes in input this vector and is able to estimate a probability for the possible actions to take in the system. And the policy network is usually a neural network. Then an action is sampled from the probability distribution. The action sampled is performed on the real system, and then a reward is observed. Finally, based on the reward, we have a backpropagation to the policy. So we change the weights in the neural network to increase the probability of the action in case the reward was positive, or decrease the probability of the action if the reward was negative. In an example with the Pong game, a possible action could be go up or go down. A possible status, input status, could be a specific frame in the game. And then the reward observation could be, after performing the action, did we pass the opponent with the pixel-like ball or not? So did we end up making a point or not? Now we have the basics. So we know what powers ChatGPT in terms of techniques and ideas. Let's see what are the steps that made ChatGPT possible. The first step is called supervised fine-tuning step. In this step, a pre-trained large language model is fine-tuned on a small human-curated dataset to learn a supervised policy. And we call it the SFT model. This model is able to generate text from a prompt. So this is the first model, effectively, that is pretty much like the final model, but it's the starting point. Then we have the reward estimation step. In this step, a pre-trained large language model is fine-tuned on a relatively larger human-curated dataset in comparison to the previous one to learn a reward function. This reward function is able to generate a rating from a prompt and a response, potentially, and is actually an alternative view of this reward function. This function is able to rank responses given a prompt. You can sort by the score estimated effectively. Finally, we have the proximal policy optimization PPO step. During this step, the reward model is used to fine-tune the SFT model with many episodes where different responses are generated from different prompts, evaluated with the reward function, and then the reward back propagated to the SFT model. You can repeat the step 2 and 3 many times, and when you get out, it's going to be a refined and more refined final ChatGPT model. Let's start from the first step then. During this step, we are fine-tuning a large language model. So we start from a large language model. Possibly ChatGPT started from the TextDaVinci 003 model, which is a model from the GPT 3.5 series. So we start from this model and we fine-tune it using a training set of couples, prompts, text. This training set is human-generated by labelers that extracted prompts from their creativity or past GPT-3 clients' queries. The size of this training data is approximately of 15,000 data points, and we have pairs of human-generated prompts and human-generated answers. Of course, this step is expensive. You can't just scale this up, adding up more and more human labelers and more human text. That's the reason of the human-based reinforcement learning. From here, you can have also a graphic example of what happens. You start from a prompt, so you select a prompt from the data set, then a labeler demonstrates the desired output behavior, which means he writes the text for the prompt. And finally, this is used to fine-tune the GPT 3.5 model with supervised learning. So this is the first step. Then we have the reward model step. So in this step, what we are fine-tuning is an estimator of relevance for a prompt and a text pair. So the scope of this model is being able of observing a reward for a specific response to a prompt. To train this model, we start again from a large language model and we fine-tune it for the task. So we take a list of prompts, we select some of them, and we make the SFT model to generate multiple outputs. Like being a probabilistic model, we will get different outputs, and we take like from 4 to 9 for each prompt. Now we ask humans to rank these responses to the prompt. And given the fact that that writing text is much more expensive for a human, in this case, it's just ranking responses is much quicker, and we can get a training set as big as probably like 10 times than the original dataset for the SFT model. What we get in output is effectively a function capable of assigning an order of preference to a list of responses from the SFT model. Effectively, sounds very familiar, right? It's pretty much learning to rank. Furthermore, this reward model can be updated with the user's feedback. So users using the real product can specify additional preference, and this preference will end up as an additional training sample for the reward model. The last step is the fine-tuning of the SFT model via proximal policy optimization. So this is the reinforcement learning part. PPO is a reinforcement learning algorithm, is on policy, which means that you are continuously update the SFT model, the policy. And it uses trust region optimization methods to constrain the chain, so to give stability. So we don't want the policy, the SFT model, to drastically change from each episode to another. So a new prompt is sampled from the dataset. The SFT model effectively is initialized as the policy, and the policy generates an output. Then the reward model estimates a reward for the output, and finally, the reward is used to update the policy, so to backpropagate the reward using PPO algorithm. This approach works with very similarly to what we've seen with Pong. So each episode is a prompt selection, generation of the response, reward, and backpropagation. If you take a look to the OpenAI APIs, you can find additional details about proximal policy optimization, and you can find that there is an updated version of the algorithm, which is called PPO2. This algorithm is optimized for GPU and has a better support for parallel training. There are also other differences, but it uses pretty much the same mathematical functions, so we won't spend much more time on this. So whenever you want to use the OpenAI implementation, please remember that PPO is obsolete and you should use PPO2. So what's the impact on information retrieval then? First of all, the boom in large language modeling means you're going to find online many different models, some of them already fine-tuned for specific tasks that potentially can be beneficial for your business or your project. You can also build datasets from your own data to fine-tune such models according to your requirements. Using reinforcement learning allows you to potentially put your effort in generating smaller datasets of fine-tuning data, and using like smart approaches like the one we've seen in ChatGPT can give you the ability of training much better models than you could just scaling up the manual labeled training samples. You can use techniques and ideas from ChatGPT to implement, for example, an advanced highlighter, for example, that taking in input a query and top K documents is able to highlight the best part of each document for your query, or summarize a snippet from the relevant documents. So give an answer based on the top K results. Or you can just fine-tune the reward model to re-rank your results. So on a pure learning to rank fashion. You can even just integrate it out of the box, adding on top of your results, like on an additional snippet, pretty much what we've seen being doing, for example, that is going soon to be released. And in general, be creative. What we've seen right now is a world of possibilities. And this is a strong enabler for new ideas. I want to close this talk with a list of references, specifically few articles about reinforcement learning that I found very useful, some short blogs that describe how ChatGPT probably works internally based on what OpenAI blogged, and the Instruct GPT paper, which I link in here in a preprint version and in the one that has been shared by OpenAI. I would like to thank all the attendees and hope to see you soon at the next London Information Retrieval Meetup. Bye-bye.